All right, we're going to begin here. This is a review again of the programming with Arduino's multiple LEDs. While we did have already one webinar recorded, this is a second webinar because we expanded on the types of loops. So I'm going to cut right over to programming two LEDs for you, and I'm going to review that real quick and then have a little bit of a challenge for you. All right, so we're going to start with programming two LEDs again. Again, this is part of multiple LEDs, but we're going to do two just to see if you can do this. Remember, we're hooking up the pin 10, pin 9 LEDs, so they're going to have resistors, orange, orange, browns at 330s. There they are. We've talked about in the past, the hot really isn't, this red hot here really isn't doing a whole lot, but we've got these pins right there. Okay, and so once we get started, we saw this when we did one pin. We defined the pin, we did the setup, we initialized that pin as an output, and then we looped it. Now we did the same structure for two pins. LED pin 1 is equivalent of not digital pin 9. LED 2 is digital pin 10. Void setup. We've got to add that then. So if we have LED pin 1 output, what would the second one be? Hopefully you're going to say LED pin 2 output. And then we'll do the same thing in the loops. So think about it a moment. What would you need to do? If you can, go ahead and do it. Pause this, do it, and then come back to me. All right, there we are. For those people, hopefully you tried to do this yourselves. LED pin 1 high, LED pin 10 high, set it low. Set it to high, both pins 9 and pin 10. That's the equivalent. LED pin 1 we said was 9, LED pin 2 pin 10. Wait a second, set them both to low. Remember, digital pins can only be both high and low, and then repeat. Now, what would be good practice is go ahead and make a traffic light. Use your existing LED setups. Don't tear up your pins. Don't worry about just having 3 lights. Just pick 3 of the 8. So your top light could be green. No green. Use red or yellow. It doesn't matter. Middle light's yellow and bottom light's red. All right, so the green light's going to go on for 3 seconds. The other 2 will be off. The yellow light will go on 1 second. Again, green and red are off at that point. Then red light comes on for 4 seconds with yellow and green being off. Go ahead, try to do that, and pause the screen now, and then come back to it in a moment. All right, this is the code. We really didn't have to do much looping with this. We've got to do a delay. Hopefully you got out of this, you were able to make a stoplight. And that's just a test to see if you understand what we're doing. Remember, we set our pin modes, outputs, and digital right. Okay? And there's our delay. There's our times. 3 seconds, 1 second, 4 seconds. I hope you're able to do that. You have a functioning stoplight. But let's go on to multiple LEDs. Here we go. Now, this involves some advanced programming, but we practice it, so I think you can do it now. So here's a hardware assembly. Again, everybody's pretty much been able to do that. Okay, there's 8 pins. If you need to pause this and set this up, go right ahead. Notice again, your ground is right here. This hot line, we're not using it in this particular, but it's there. Your hot really is going to be provided by these digital pins over here. So they're going to be hot, have current, and your ground's going this. We're really not using this red rail right there on this. Now let's go ahead. Let's look at programming it. Now, if we just did 2 pins a few moments ago, we could try to do the same thing, and maybe we just set pin mode to, we'd have to do that for 8 pins. So you'd have something like this: integer LED pin 2, integer LED pin 3. That is a lot of work. Instead, let's use loops, and let's think about when we were using Scratch and loops. You're going to set your count to 0. When flag is clicked, set count to 0. Pick a random number between 1 and 10. Change count by 1. What that's doing though with that set, you've got a repeat loop inside here. And that's what a for loop on sketches were going to be forever. All right? When we just have void loop parentheses, that's going on forever and ever. A for loop is like this repeat. There's a certain number of times it's going to go. So if I wanted to count from 0 to 9, start with 0, it would print 0. The next time up, I'd add 1 to it. That's what that plus plus adds to that variable counter. So we'd have counters now 1. Is that less than 10? Print 1. So the counter, we should explain here, is set originally to 0. It's going to be, this loop's going to continue until it's less than 10. It's increasing by 1 each time through. That's what that plus plus says. And you have print lane counter. So if we want to make pins 2 through 9 output, this is what that does. It says pinMode counter output. So it's making all of them output. Well, what's counter? Well, it starts off as 2, then it's going to become 3, it's going to go up to 9. When it gets up to 10, it's not less than 10 anymore, and it'll stop. So 2 through 9 will instantly become outputs, which is a lot better than having to type all of this out. Next, so let's go ahead, do that void setup, and go ahead and add that little bit of code. All right, if you need to pause, go ahead and pause. Now, so that's under void setup, let's go to void loop. Again, same kind of notion. We are counting the different pins to set them to high, then we're waiting a second and then setting them to low. So the first time through, this would be pin 2, so digital write pin 2, make it high, wait a second, digital pin 2, make it low. And then go up, make it 3, 3 high, 3 low. So each pin is going to blink one after another. It's going to blink on and off and go up through the whole pins from 2 to 9. If we did it as an array, or if we did it even just pins, you kind of get the sense of how much code we'd have. And it just physically doesn't make sense to copy and paste. Let's use for loops instead. Now let's go ahead and start messing with this a little bit. We can really have a lot of fun with these LED lights. Let's add another loop so all the lights flash on at once and then all shut off. So what we do in here is, again, void loop, but we're going to add an additional loop right here. So in other words, let's turn them all on. This loop now is going to make them all turn on, and this loop is going to make them all turn off. So in other words, it's going to loop 2 through 9, set them all to high. Then, wait a second, loop 2 through 9, make them all low. Go ahead and try that. And then I'm going to challenge you right now. If you've done that, you've gotten it to work. How could you make it so pins 2 through 9 it becomes high, but then starts 9 back to 2 going low? So it goes up and then starts coming back down. All right. So, excuse me, that's one thing to do. Also, another thing we can do is we can do a delay. So this happens almost instantly. How about if you want to see the LEDs one after another? And that's what this one's going to do. There's a delay in between as we go through this. Let me pop this up. Right there. So this is all the code. Let me get this confusion here. This is all the code right here to go ahead and make that happen. Now, let's show them popping up one after another. We add that delay 250 right there. And what that does is it pauses as it loops through each one of those lights. Okay? Go ahead and try that if you haven't. And please be saving these as you go through this. All right, all the pins are set to 9 are set to high. Then how do we turn the pins off? Then 8 and 7, like I just mentioned before. You're going to need this greater than equal and counter minus minus. So for integer counter 2, counter 10, counter plus plus, pin mode counter output. For integer counter 2, counter less than 10, plus plus plus, digital write high. But now here's where the difference is. counter 9. We're going to start at 9. We're going to go down till it equals greater than or equals to 2, and we're going minus minus. So this way, they're all going to light up bright 2 to 9, and they're going to start at 9, back down to 2 and low. So go ahead, take a moment and try that. All right, now we're going to talk about pulse width modulation. That is the idea that we can make a digital pin, such as an LED, look like you can make it so it appears to be fading. Remember, we said something digital is either on or it's off. So it's on or it's off. Well, we can use the fact that during the duty cycle of the computer as it runs, at 100% duty cycle, the LED's fed 5 volts the whole time. But what we do, if we turn it on just for a period during that duty cycle and we make the period shorter and shorter, we can fool the eye into thinking it's dimmer. We use pulse width modulation to PWM or pulse width modulation to fade LEDs. We can also use it to control servos, do some really neat things with it. All right, so there we are. But not all pins are PWM capable. 3, 5, 6, 9, 10, 11 are. And just keep that in mind. All right. 3, 5, 6, 9, 10, and 11. And here I have it hooked up, set up in such a way that only the LED pins. Now on this program, it makes it look like these are, even though it doesn't have the little PWM type that you see here and here. So if you're using one, this is coming out of 123D circuit. In reality, those are too, and I've tested it and it does work. Okay, so let's dim light 3. Pin 3 is PWM capable pin. All right. It can range, when you use a PWM, you now use analog right. So analog right is 3255, and that sets it to its brightest. And if you wait, you set it to 350, it could be anywhere from 255 to 0. It blinks, but it doesn't go completely off. Something very on before, it was either on or was off. And go ahead, you can try some different values there. Try 3, set it to 255, then say 3 to 100, 3 to 50, 3 to 25, and you can see a difference. Let's make the LED look like it's sleeping. In this case, what we're going to do is we're going to have a loop. Before, up into this point, we were looping through the pins. Now we're looping up to the power, because remember, this can go any power in analog right from 0 to 255. So this same pin 3, we're going to start off at 0 and go up to 255, be your brightest, and then start at your brightest and work your way back down. Go ahead and try that. And again, only one pin is going to go on LED pin 3. We set the output there. Now, let's look at pin 3 and pin 2. Okay? In this case, if we use pin 2 as an output, we add that back up in there. Then we use the digital write 2 high and digital write 2 low in this situation. And you're going to see a stark contrast. Either pin 2 is on high or it's all the way off. All right? And remember to be saving these. All right? Make sure you're saving them. And also make sure sometimes pin 2 will have a little bit of that light LED will reflect on the other pins. So just look at the pin 3 and notice how much brighter and then dimmer it gets, where pin 2 is either high or it's low. All right. What if we wanted to make all the PMWs breathe? We need to learn about arrays. All right. So here's how we do arrays. Arrays, if you go back into Scratch, are where we use lists. So you have a list called cheers, and but you want all kinds of different cheers, and you randomly want to come up, because if somebody's watching this match of some sport, they don't always say the same cheer. They say different ones, like hooray, you can do it, you're amazing, all right. This are all part of the list cheers, but it allows us to put these different statements in there. And if you think about it, item list item 2 we can refer to as cheers 2, cheers 3, cheers 4. Okay? Now, arrays are a collection of data types, integer, float, character, strings. They can be anything. Arrays save us from creating lots of different variable names, but more importantly, arrays help us write better code. Each member array is identified by an index value. If an animal is an array, then animals 2 is a member of that array. So let's ask yourself some questions. How many animals are in this array? There are 8. What animal is animal 3? That's animal, parentheses, 3, parentheses, 3. That's the indice of the array animal, and this 3. Well, there's the member 3. That's horse. Notice that's the fourth one down. We start with 0. What is animal 5? Cow. Why does the index array only go to 7? Because we started at 0, so that gives us 8 member animals. Why does the array start at 0? It saves us memory space. We don't waste that 0 slot. All right, now here's an example. We're going to have an array called LED pins, and it's got members 3, 5, 6, 9, 10. You know, before we had just LED pins, and then we might say equals or assign the value 3. This allows us to assign all these values, and we can separate them by their indices. So if you saw LED pins bracket 0 bracket equals, all right, so if you see LED pins 0 bracket, that's the same thing as 3. If you see LED pins bracket 2 bracket, that's 6. And the reason why it's 6 is with 0, 1, 2. And that's why it's 6. It's the second indices. LED pins 5 is 0, 1, 2, 3, 4, 5. So LED pins 5 is equivalent of 11. That's what the computer is going to see. Can you make your PMW capable of lights breathe? You'll need to use array and multiple loops. So this is we're going to set it up. We start off of defining our variables so it can be seen throughout the program outside the void setup loop. You have LED pins bracket 3, 5, 6, 9, 10, 11. You have void setup, and then you have void loop. We're not going to worry about void loop on this side. It'll be on the next slide. But on this, notice we're going for integer counter less than 6. And what we're doing is saying pinMode LED. So we're in that array. We're starting with counter. So it's going to start at 0, and then it's going to end at 5. So it's basically going to say pinMode LED pin 0, which is the third LED. And then this will be number 1, which is the 5th value. It's a little confusing in the beginning. LED pin bracket 2, which is the second, or excuse me, LED pins bracket 2 is the third member, which is the same value of 6. It's going to make them all outputs. We can't just use a regular counter in a PMW because it doesn't just work 2, 3, 4, 5, 6, 7, 8, 9 like we did before. In this case, we have to go 2, 3, 5, 6, 9, 10, 11. Now on the next slide, all right, for integer counter 0, counter less than 6, we're going through there. We're going through all our loop of our array. But then we add the second loop. So this second loop sets a value of I from 0 to 255, because that's less than 256 increased by 1. So what you've got is an analog write print the first member of the array and then set it to I. So when it goes the first member array, this will go up in value 256 times. And then it'll go to the next member of the array and go up, loop again to 256 times, and vice versa. So slowly it's going to bring every one of them up, slowly going to go from 0 up to full brightness. Then, same loop again, but this time we're going to go from the brightest down to dim. So go ahead, try to write this code. Can you go from 3 to 11 brighter and then dim 11 to 3? So can you go from 3 to 11 brighter and then dim 11 to 3? So can you make it brighter and then dim it? All right. So this time we change our counter. And instead of the last time we kept starting at counter 0, less than 6, now we're starting counter 5 and we start dimming it. So what's going to happen to It's going to go up using this. It's going to go up to pin 11, make it bright. And then it's going to start at pin 11 and get dim, and then go to pin 10, then go 9. Go ahead and try this. All right. I'm hoping you're finding this whole LED. They call this LED light sculpting. I think it's pretty cool. You can do more. You can spell out your phone number. You can play with this and all kinds of different ideas on different blinks. You could do, if you wanted every other light, you could do, instead of plus plus, you could do +2. You can try out different ideas. All right? And that's all we have on multiple LEDs. Thank you.